Today we are going to begin to learn how to use MATLAB and Python. I've already provided a short video on what MATLAB and Python looks like. I would like to refer you to those videos before proceeding. Before we begin, please pause this video and open MATLAB and/or Python, whatever IDE you are using. Whenever you are ready, just go to the next slide. We'll begin by defining some of the common terminologies that we will be using when programming. A command is a simple instruction for the computer. The best way to teach this is to give you a few examples. But before you proceed with the video, please take note of these commands. You can pause the video at this time and press play again when you've taken notes. Here in the workspace, you can see all the variables used for the falling parachutist. The command clear in MATLAB clears the workspace of all these variables and resets them to 0 value. The command clf in MATLAB clears all figures and resets them. Let's do some math commands. If I want to round off the number 30.7945 to the nearest integer, I can type the command round 30.7945 and get 31 as expected. I can even round the same number up to the first decimal place and to the second decimal place. The command power 23 solves for the cube root of 2. Alternatively, you can type in 2 raised to the third power with a caret sign indicating that you are raising 2 to the power of 3. Finally, I can use the command clc to clear the command window so that I can get a clean slate. Notice that any output as a result of executing the command is automatically assigned to a variable called ans. Ans is short for answer. In Python, there is no built-in command analogous to clear, clf, and clc commands in MATLAB. That is because you don't need it. In Python, the command console or interpreter console is hardly used, just as in MATLAB. If you want to do short tests or demonstrations, you can try them out in the command console. In MATLAB, you create a code or a program in a script file with the file extension *.m. It's good practice to use clear, clf, and clc inside the script prior to all other commands because MATLAB remembers all variables. In Python, you create in a file called *.py. The clear, clc, and clf command is not necessary because the variables are unique to the project. Besides, you can create directories or tuples in Python. These types of variables are practically unchangeable and are designed not to be overwritten. The round and pow commands are practically the same for both MATLAB and Python, except that in Python, you need to call the library where these commands are located. These are obviously mathematical functions, so these commands are located in the math library of Python. Secondly, you will need to use the command print to be able to show the output. A syntax is the correct way of typing a command. In both MATLAB and Python, when you begin to type in a command, it will show you the correct syntax. For example, in MATLAB, the correct syntax for raising a number to a certain power is power open close parenthesis, the base number, comma, and then the exponent, and then close parenthesis. In Python, the correct syntax is pow, open close parenthesis, base number, comma, exponent, and then close parenthesis. You cannot use pow in MATLAB. Since it will not recognize the command and the syntax is incorrect. Also, MATLAB and Python will require you to place at least 2 parameters within the parenthesis. Any parameter inside the parenthesis in any command is called an argument. Thus, 3 is an argument and 2 is an argument. 3 is an argument of power and 2 is an argument of the function or the command power. The arguments of the command power are the base number and the exponent. Furthermore, the separator between these 2 parameters is a comma. Using a semicolon like so, in MATLAB is incorrect, and MATLAB will send an error message. It is the same case for Python. In MATLAB, you can also use base number.caret exponent as shown. To obtain the power of something raised to something. Rounding off numbers are the same in both MATLAB and Python. You use the command round with open and close parentheses. The first term inside the argument is the number to be rounded off, and the second term is the number of decimal places. If you don't place the second argument, MATLAB and Python will use the default value of 0, which means that it will be rounded off to the nearest ones. In MATLAB, you can always type in the command in the search documentation field at the upper right to determine the correct syntax. In Python, there's a search field at the upper right corner. You can also type in the command you wish to know the syntax of. However, Python's help services are a bit too technical, and you have to really familiarize yourself with the technicalities. The Spider IDE has a much better interface than PyCharm. You can see the commands highlighted in a different color, depending on your background settings. Scroll the mouse over to the command you want to know, and then press Command I in Mac OS or Control I in Windows. A code or a computer program is a series of instructions for the computer. Here's an example of a MATLAB code or program. This program solves for the value of the sine function from the value of -4 pi to +4 pi. The series of instructions has to be in the correct sequence. This step-by-step procedure in writing down these lines of commands is called an algorithm. Thus, in order for the program to work, the correct algorithm must be written. In this program, the first line, line 1, is a comment line. MATLAB will not do anything that is placed after a % sign in any line. The next line shows 3 commands. We've discussed earlier what the clear, CLC, and commands do. For aesthetics, and to see the lines of code better, I added a blank space in line 3. In line 4, I defined a new variable, range, and I assigned it a value of 4pi. This helps me define the range of time that I need for my sine function. In line 5, I have defined a new variable called t. This time, t, I am assigning not just one number but a series of number or an array to the variable t. The minimum value of the variable is negative range or negative 4pi, and the maximum value is positive range or positive 4pi. I chose the interval or the step size to be 0.1. This will give me 252 values for the variable t. If that is confusing, I'll show you a much simpler example. Okay, let's use the same variable t in this example. So I want to put the values 0 up to 10 in the variable t. So I will make a new variable t and then equate that to the minimum value of 0. Okay, place a column between the minimum value and the maximum value 10. Okay, and if I put a semicolon here, okay, the values of t will not be shown. Okay, what I mean is, if I don't put a semicolon there and if I press enter, okay, you see all the values of t. Now t has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 elements. So now t is an array with 11 elements. If I put the semicolon, like so, okay, then MATLAB does not show all of these values. Notice that after I press enter, the variable t can be seen here in the workspace. And you also see the value or the type of numbers or the size of the array that corresponds to the variable t. It's 1 by 11, so it's 1 row by 11 columns. So t is an array and t is also at the same time a matrix. I can double click this workspace, okay, and double click this one. Okay, you can see here the values of the variable t. Okay, there. So, what if I want to assign a different step size? Okay, so let's clear this variable. So I have t equals 0, and I want to assign a step size of 0.1 or 1 over 10. So 0.1, and then 10. Okay. Now I won't put a semicolon so that we can see all the values. Okay, if I press enter, then I have all these values for the variable t. You can see that it starts from 0, and the next number is 0.1, 0.2, 0.3, because I assigned a step size of 0.1. Okay, so now this variable has a size of 1 by 100 elements. So it's 1 row by 101 columns. So this is an array that is 1 by 100, or a matrix that is 1 row by 101 columns. In line 6, I have assigned the new variable y to be equal to the sine values using the equation y equals sine t. The variable y will have exactly the same size as the variable t. Line 8 tells MATLAB to create a figure and label it as figure 1. Finally, line 9 plots the sine function using values of t as the x-axis and the values of y as the y-axis. Note that the correct syntax for the sine plot function is that the first argument is the variable to be assigned to the x-axis, and the second argument is the variable to be assigned to the y-axis. The third argument uses a circle instead of a dot to plot the values in figure. We'll talk more about what are called specifiers in the next video. If we run the program, we'll see the figure generated by the plot function. We can change the color to blue, for example, or if we don't put the letter there, the default color is blue. For black, we use the letter K. We can also change the symbol that is used from a circle to an asterisk. Or if I don't use any of these specifiers, it'll just give us a line. I can also change the interval. Okay, and you'll see that there are more data points because I changed the interval. Now T and Y has 2,514 elements for both. If I say, for example, that I place the command in line 6 before the command in line 5, then MATLAB will produce an error. You can see the error in the command console. The error message reads unrecognized function or variable t. That's because I commanded MATLAB to solve for the sign values from the variable t without defining the variable t first. The whole point of this is that every command has to be in the correct sequence, or the algorithm must be correct. In Python, the code to print and plot a sign function looks like this. First of all, you don't see the clear CLC and CLF commands as they are unnecessary in Python. However, the first two lines of the code calls for the import of the two libraries, the matplotlib.pyplot library and the numpy library. The numpy library contains all of the necessary functions and commands in order to perform mathematical equations and set up arrays and matrices. The matplotlib library contains all of the necessary functions and commands for visualization, such as plotting. Thus, the command import tells Python to import all necessary visualization functions from the matplotlib library and refers these functions to a local name, which in this case is PLT. In the same way, you are importing the numerical functions from the numpy library and refer them to the local name NP. When we say local, it's unique to the project or the script that you're working on. In line 4, the variable maxVal is assigned a value of 4pi. Note that I could not use the variable name range in Python because Python recognizes it as one of its commands. Also note how I defined pi. I needed to use the pointer np to refer to the library numpy in order to be able to use pi. The variable t is now assigned values from negative 4pi to positive 4pi with a step size of 0.1, as in the MATLAB code. However, the command is different. In MATLAB, the assignment of a variable to a set of numbers is straightforward. In Python, you need to use the command arrange. On top of that, you have to use the local name np referring to the library numpy in order to use the command arrange, which is contained in the library numpy. In line 6, the variable y is assigned the values pertaining to the sign of time t. You will notice that in the use of the function sign and the constant pi, the local name np is used. Again, this is because the sign command and the pi constant is contained in the numpy library. In line 7, the plot command is executed. However, the plot is not yet shown. In order to display the graph, the command show in line 8 must also be typed in. In both commands, the local name plt is placed before the commands in order to refer to the library matplotlib. Now let's run this code. The resulting plot can be seen here in the Plots tab. You can see that Python is a little bit more complicated, and the complication arises from calling the necessary libraries. We'll be working more with libraries in the future, and I'll introduce them to you as we progress. I have placed some documentation that you can read for these two libraries in the supplementary section about the course, just in case you are interested. All of these commands are the same in MATLAB and Python, except when there's a slash followed by blue characters. The character before the slash is unique to MATLAB, while the character after the slash is unique to Python. The cotangent function is unique to MATLAB and cannot be found in Python. Just a note, use parentheses to indicate a prioritization of mathematical operation. Otherwise, MATLAB and Python follows MDAS rule. When programming, you'll encounter errors. Take note of the error and remember it. You can ask me what the error means during our consultations or by sending me an email or a message. Then remember how the error was resolved. I hope that you've learned something from this video. The only way to truly learn is to practice. In the next video, we'll try to solve for the roots of the quadratic equation. As an ungraded exercise, you can try to make your own code in MATLAB or in Python. Then when you've finished, let's compare programs and evaluate how much you've learned.